Hi, I'm Zachary Douglas, and this is my Mechanical Engineering 341 Thermodynamics project. And the system we will be analyzing today is my PC cooling system. The boundary of this PC cooling system is just the general computer case. This is because there's one inlet on the back of the computer case, and then two exits right here and right here. The heat sources of the computer is generally the computer processing unit, the graphics processing unit, and the chipset. This is the computer processing unit, the graphics processing unit, and then the chipset is down here. Each of those have an integrated heat sink. This is just a piece of metal that takes the heat away from the actual chip and then transfers it to the base of the actual heat sink, and then that base transfers it to the heat pipes of the heat sink, and then into the fins of the heat sink, which look exactly like this. Then from there, the airflow of the case takes the heat away from the heat sink and out of the case. And how this case is set up right now is I have two parallel fans running as inlets, so the air comes through here and then goes to the graphics processing unit or the computer processing unit, and then these two fans right here and here push the air through the heat sink, and then these two fans right there and there push the air out of the case. And then basically how you could set up these fans, this is a parallel configuration, this is more for airflow, and then the way I have these two fans set up is a series fan configuration, and the series fan configuration allows for more of a static pressure through something like a heatsink. For my first concept, I will be explaining how the computer cooling system is actually an open system, and this is from chapter 1. The mass transfer of an open system for this case is through the inlets and outlets, and the mass that's being transferred is air, and this is by the computer fans, of course. And then the energy transfer is through electricity and heat, and the heat generated is from the voltage going through the computer processing unit, graphics processing unit, and the chipset, because the set amount of voltage that they work at generates X amount of heat. For my chapter 2 concept, I will be introducing how the computer transfers the heat away from the CPU and GPU and then the chipset, and this is through conduction initially from the internal heat sink to the actual heat sink, and then to the air surrounding it and moving through it, and then from there it uses convection to move heat throughout the case, and this is also aided by the airflow from the fans going in and out of the case. Third concept, I will be talking about how the case adheres to the ideal gas laws and concepts of chapter 3. And then this is only because you can assume the air is modeled as an ideal gas, and then you can, of course, use all the PVRT equations to determine temperatures, pressures, volume, and then, however, the PVRT equations won't be as realistic as simply measuring the temperatures through software. For my fourth concept, I will be talking about how my computer does not actually operate at steady state, and this is from chapter 4. This is mainly because the mass rate from the inlets and the outlets are completely different, and this is because of inlet and outlet size, fan placement, what types of fans you have, whether they are static pressure, which is used to force more air through something like heat sink, or whether they are airflow fans, which are just meant to push as much air as possible, as quick as possible. And this essentially leads to the system not being in steady state. For my fifth concept, I will be talking about how my computer case adheres to the Clausius statement of the second law of thermodynamics from chapter 5. And this essentially means that my computer transfers heat from a hot thermal reservoir, or the computer processing unit, to a cold thermal reservoir, which is just the ambient air around the computer case. And obviously this does this through the use of the heat sink, which pulls it away from the computer processing unit and then through the airflow from the case using convection.